everybody? Let's get this show on the road. Hey everybody, hope you're doing well today. Welcome back to another edition of Zephyr 101. This week, per community request, let me see if I can get this. We're going to be covering, let me see if I can change some of these things here. There we go. We're going to be covering ZBus. So last week, if you haven't checked it out, I did a thing on where I was setting up a way to kind of safely send messages back and forth. Let me see if I can fix this here. 1 second. All right, let's try that again. Sometimes my OBS needs to be restarted. So we're going to be talking about some stuff. The ZBus. And last week I was covering kind of a configuration that I set up to send messages across an application to make it a little bit more reliable, especially across threads. So that's what we're going to be touching on today. But instead of doing something like that, we're using kind of manual message queues and kind of structures like that. We're going to be using ZBus instead. I actually created a sample. If you check it out in the description box below, I did a link to it so you can check it out. Kind of what I did. I was using the NFED, so the NRF9160 Feather examples and drivers. I built a separate accelerometer sample, so it takes the accelerometer data and it puts it. It sends data across different threads using ZBus. So that's what we're talking about today. If you haven't already, hit that like button, hit the subscribe button, and leave a comment. I love to hear about your thoughts on this or anything else you'd like to see covered on the channel. Today, obviously, was a suggestion from the community, and actually there was one community-based question that came up just before I went live here, so I'll cover it as well because it's an important topic. So we'll be doing that. Now, some of you might have gotten my email this past week. Golioth is hiring, so I'm just spreading the word. Golioth is a good partner and friend of the show, so I just want to spread the word that they are hiring. And if you're, if you love Zephyr, they primarily do everything with Zephyr. So they are hiring some engineering management and also an FAE. So if you are interested, check them out and let them know that that I sent you. So now, next, here is the question. So this is from Erwin. He sent this to me earlier today, or actually yesterday, and I had replied, and he was like, "Okay, I'm still confused, or it's not so straightforward. I was using this sample, and it's just not working." So, let's jump in. So what I did is I actually went to the sample, and I went to the sample, and I wanted to compile for a new board. So if you go to that particular sample for this driver, so if you go to Zephyr drivers, sensor SM351LT, you notice there were no boards, no overlay files for it at all. So if you want to add that to, or if you want to use your board with that specific driver, you need to make sure that it's defined in your overlay. And not more importantly, but both together, is that you need to make sure that anything specific for that particular driver or anything specific for your board, you need to make sure it's defined in your board configuration, and then also add the device in your overlay. So you need both for things to work. So here was the example of the overlay that I would do for the NRF9160 Feather if I had it hooked up to pin 31 on port 0, and I just made sure that you have to wrap it in that / in those brackets, or else it won't be able to find it. You actually get a compilation error. So he was having an issue because it was complaining that it wasn't able to find the driver in question, and all it was that he was missing one of the elements in question, and all you had to do was just add an overlay. So pretty straightforward, fortunately. So don't forget the overlay. So all I had to do is for the Enter for Anyone 160 Feather, I created a boards folder and put the Circuit Dojo Feather Enter for Anyone 160 NS.overlay in it. I'd probably, if I didn't already, I did a pristine build to make sure it actually found it. Often a quick tip trick here is that whenever you're adding something like an overlay or a configuration, Zephyr might not know that it's there until you do a pristine build or you delete the build folder. So make sure you do that when you do add those things. So that's it for that question. Now we're going to move on to the main attraction, which is ZBus. So ZBus is a fairly new, I think within the last 3 months or so. It is available on the latest version of both NCS, which is 2.3 as of today, and the latest version of Zephyr. It's been released in mainline Zephyr for a while, but you can get them in either one now. Nordic, I tried it with 2.2 in NCS, but it didn't have it pulled in yet. So the idea here is that you can share safely some data, kind of these data structures between threads, different contexts in your code. It kind of has this, you can send data to one-to-one, so you can send from one thread to the other, or one kind of publisher to one observer. You can have many observers with one source, or you can have many, or you can have many threads that are creating many events that are going to many things. So we're going to be mostly, we're going to be concentrating on just the one-to-one, keeping it simple here, but you can see that this is a pretty powerful system. So the cool thing is, so in this case, like I was alluding to in the previous slide, there's a bunch of different configurations. You can, if you do the one-to-many or many-to-many, you can basically kind of broadcast to all code that might be interested in that data. And the biggest thing about it is that you can kind of contain your code and kind of separate it out. I am guilty of having these monolithic main files, which is kind of crazy. I know a lot of people are very into the kind of micro architecture, the micro of like different, having our microservices, having different kind of services, things disparate from each other, and then you kind of just send data back and forth. So that's kind of the idea, but in an embedded layer. And I will add the Rodrigo, the author of ZBus, actually had a great conversation with Chris over on Golioth on their channel. So I actually linked that video below. So it's a good introduction to ZBus if you're just starting out. So I watched it before I played with it a little bit more in detail. Did I get everything on that? Yep. Some of the disadvantages, it does take some time. So it took me a couple hours to or an hour or two, to write some notes and get a working example going and just playing with it and breaking it and seeing what worked and what didn't. The one downside is in certain cases that if you're using a particular type of observer, and we'll get into that in a second, but if you do use a particular type of observer, there is a potential of losing or missing data because essentially it gets overwritten. You might have to reorganize your code depending if you're starting from scratch or if you're integrating it into an existing application. It's going to take some reorg, and it's not really good if you want to make sure, kind of going back to the second point there, it's not very good for keeping persistent data. So if you really care about that data and you want to preserve it as much as possible, you're still going to probably end up using a separate message queue somewhere in your code to do that. Here's the configuration. The biggest thing here is just enabling ZBus. All these other things are more debug related. So I just enabled the log and just observer channel name, and just for usefulness as I was debugging things. As for the overlay, there's nothing necessary. So there's no changes in your overlay or anything like that are required. So the concept in ZBus is that And you might find this similarly in different areas in computer science, in programming in general. I know there's concepts of channels in other languages, like C, like higher in terms of operating system concepts. There's ideas of channels, so this is kind of a similar idea. So you have a channel that we want to define, and you give it some information, i.e. what the structure you're going to be sending across that channel. And what this channel essentially sets up is you're setting up a static piece of memory to hold that particular piece of data, and you're facilitating kind of notifications and things to let other parts of your code know that there's data available. This is all commented here so that you can kind of see. This was actually commented from one of the samples, and I just kind of made it my own. And if you go here, so the general idea of using that macro is you define the channel name, you define the structure. So you're actually providing that struct, so it'll provide a size of, so they can, so at compile time it can kind of figure out how much data it needs to store. That first null is actually, if you'd like to, you can actually validate the data before it gets sent. This could be useful if you're generating events, but they might not have useful data, so that's interesting. You can also have a piece of data that you can share into or across events and across listeners and observers. This might be useful if you have a shared context that you're using to kind of define the functionality of your application, I guess you could say. You can, and then defining, so one thing you can do also is you're defining the listeners / observers. So listener is one type of observers. I meant to write the listeners and subscribers. And then you want the last entry there is setting the initial value, which is usually just 0, but sometimes you can set it to initial value or whatever you need to, depending on the situation in your code. So let's take a look. So I just mentioned the subscriber and listener, and these are considered observers. These are the things that are actually going to be listening in these are the things that allow you to receive the messages when they're being sent into the ZBus. So there are two different distinctions between the two, and we'll jump into that right now. So listeners essentially are kind of callback functions that get called immediately when you push. So this is the way that you can get things immediately where you don't, and there's no loss of data. Versus subscribers, it's more of a queue structure. So what happens here is you do the push event, and then if you have another thread that's listening for these things, then it'll kind of pop off that event and then read the data. So if you have a bunch of events at the same time with subscribers, you can actually set a limit of how many events that you want to be able to queue at the same time. So imagine it like it's the functionality of a subscriber is more of like a, hey, I had an event happen, let's check it. And it's kind of hard to explain to somewhat, but the thing here is there's only one area where your data is stored, and it will always have, that data will always be the latest up to date. Whatever the last push was, it's going to reflect that data. Hopefully I just didn't confuse the crap out of you guys. But here's what we'll go with, this is what the subscriber is. So this is what I'm talking about here. You have that subscriber define macro, and that's allowing you to define the subscriber that we're actually going to be listening on. And then that subscriber, if we go back, let me see, I believe you can see that we're using that same, so we're defining it in the ZBus observer. So you can define multiple observers here in that, but we're only defining one in this case, which is the sample start sub. And we have a separate thread, and this thread waits infinitely on this subscriber, and whenever something happens, it will release this thread and allow it to run. The thing is, we're using the lowest application thread priority, so this could happen at any point in your code. This is particularly useful. So in this case, this subscriber is actually used to kick off a sampling over I2C. So it allows you to set up a thread that's dedicated for any type of IO operations. So you're not having any kind of bus contentions or anything that's going on at the same time. If you want, so this would be my like I2C thread. This would be everything that I'd be doing on I2C, and you can kind of mold it in the way you want it to, but that's the way I would do it for sure. So the subscriber is used to listen, and it's on a kind of more of a polling process, and the like I said, it's going to be listening for events, and it's going to process them as needed. So you're creating it with that macro. The first argument is the name. The second is the amount of the events on the queue. So like I said, it's kind of weird because you're actually only, when an event happens, you're pushing and updating the data. But then you're also pushing like a reference to the channel in a queue that when you have the processing thread, it's going to say, okay, is there any events? Okay, I got an event. I'm going to move to the next event. And then it'll empty out that queue, but it's really only just checking, see, okay, I had an event on this channel. And then it's like, okay, cool, I'm going to do something. So really it's kind of essentially creating like a counter to some extent, where it's like you're increasing a count of something and then you're kind of undoing it as you do some processing. So you might have in a case where it's like, oh, I want to read a sensor 5 times. So I'm going to send a push event for 5 times. And then I'm going to have it on the other send, unravel it, and actually take some samples. In this case, take it 5 times. Do have a question from Brian. If your subscriber queue is and a new message is published, do you lose the newest and oldest message? So that's what I'm trying to get at, which is kind of hard to explain. It took me a little bit to get it, but the idea here is that for the subscriber queue, all it's doing is pushing a reference to that channel. That's it. So, and it'll update the data to whatever the latest is. So if you have a bunch of push messages and there's actually data in there that you're trying to save, it's going to overwrite everything. So it'll overwrite all the data and keep the latest. So you will lose. So that's one thing I was playing around in that sample, is to make sure that I was like, okay, it has a queue, but how does this work? Because I right before I was using a message queue to actually save that data and make sure it was persistent. So I was like, oh, maybe they actually did that, but it's not the case. You're not saving the previous entries. So. Yeah, the queue is only for, I was just going over to the pointers. So another way to do it is you can set up some callbacks using a listener instead. So this is going to get called immediately whenever you have an event. And here is a listener, an example of a listener in this case, where I'm actually listening for the I2C data on the other end. And you can see here, I'll go into the ZBus chan const message here that will actually, that function is particularly important because you can get a pointer to the data involved in the process. Thumbs up from Brian. All right, good. So to define a listener, your first argument is just the name. The names are important here because you're also referencing them when you're initializing the channel. And the second is the callback name. This is the callback that's getting called back when you're doing a push. And you can get the data, like I said, using that ZBus chan const message. So this is kind of cool because you're actually efficiently fetching the data from memory using a pointer without doing any copying. So handy. I can imagine listeners are useful for per se if you have an event where like if you have accelerometer data And then what you want to do is save it to memory, and then maybe you save it later to flash. You can, in that callback, you can actually put it on the message queue, and then later on you can save it to flash. So then you can take it out of flash later, encode it, publish it, whatever. So that is just an example, and that way you don't lose any values when these come across. Another important aspect of this is that so you have a ZBus, cool. It's kind of difficult to access these things. So maybe you set the channel up in one file, but how do you access it in other files in your code? This is the way it's done. So this creates an extern of your channel. So you have the channel defined somewhere else, and then this is in a separate folder file. So say you defined your channel in your main, but you need to actually push to that channel from maybe a sensors file. That's how I had it in this example. You guys can check it out. But if you try to use that channel, it's going to say undefined, unknown. I don't know what sample start channel is. So the way that you can kind of connect the two pieces together is by using this ZBus chan declare macro. And you really only need to do, so if you're doing a push from the same file, so if you're doing it in main and you're doing a push there, you don't need to declare it twice because it's already declared. It's the same idea of kind of externing like a structure or a piece of data and then defining it elsewhere. So in this case, it's just a macro wrapped around that idea. So without it, you can't use it. You can't use it and you'll get compile errors, most likely. Or you'll definitely at least get warnings, depending on how things are set up. And finally, probably the most important part is actually publishing. So what I've done here is I set up my structured data to have a timestamp and also just a generic Zephyr sensor value. So then I get the sensor value from the driver. As long as it's successful, I'm going to publish it using to the ZBus channel, which is the sample data chan. So I'm providing a pointer to the data channel. I'm providing a pointer to the data. And then there's also a timeout. So the timeout it's just in case, because it needs to be thread safe. So there are some kind of, as you can imagine, some kernel magic happening in the background in terms of mutexes and things like that to make sure that there's nothing else using or writing to that channel at the same time. So if it gets locked up or if it's still being occupied for whatever reason, then these timeouts come in handy. Obviously, the one important thing that I saw in the documentation in general is just a good practice is that if you're using this system, if you're using ZBus, you need to make sure, most importantly, that the callbacks, so the listeners, you're processing them as soon as possible, because those are actually locking, it's holding the ZBus from being used by anything else. So that's critical. You just got to be careful of that. So for me, I kind of alluded before, is that if I was using a listener, I would then, in that callback, it'd be message queue, push it on the message queue, done. That's all we're doing. You want to make it very fast, very quick. It's kind of the same concept if you're using an ISR. You want to make sure ISRs are very, very small, very compact. That way it does some processing and then, lets the processor go back to the main thread and whatever else it was doing. So, so once it's, and then everything gets published out to the observers, listeners, and or subscribers, and then they do their thing. So I like ZBus. It's cool. I think I'm going to be looking into more ways of using it. I do have one client project that probably could be using it. I think I'll venture into seeing if it's possible or feasible. A lot of the code, a lot of the applications that I personally write are kind of data collection, things like that, where event collection, you're saving events to disk, and then you're recalling them later, you're encoding them, maybe batch encoding them, sending it to a backend. So, but for a cross communication / if you're kind of trying to send data between different modules, I think this is a great solution, and it's just a great addition to Zephyr for sure. So, and it just makes things, you know, flexible. The only thing I would say is it can't do everything. You can't, kind of what I was saying before is that you can't save sequential events in memory. It's only going to save the latest one. So you're still going to be using message queues. You're still going to be using FIFOs or anything else like that. So depending on your application, both accomplish the same thing. One does it statically allocated and one does it dynamically allocated on the heap, i.e. the FIFO uses the heap. So, and that is quick and dirty 20 minutes ZBus. There's a lot more to go over, and if you'd like to see maybe some more advanced examples or anything like that, please let me know. Also, feel free to subscribe at my mailing list at jaredwolf.com. I tried to send out messages throughout the week, also just reminders for these videos, yeah, just try to stay in touch with the community. Obviously, I don't spam anybody. I only send maybe 1 email a week, 2 emails a week, depending on the situation. So, and I have messages. I have messages from the inspiration, Mr. Franz. Thanks. I like this topic. Very useful. Yes, I agree. And thank you for your suggestions last week. It prompted me to look into it pretty much the same day to see if it was something worth talking about. And here we are. So thanks, Franz. Really appreciate it. I don't think we have any more questions. I know it was a quick one. There's probably a lot to digest in that one, especially the differences between the listener and the subscriber, and then how the push events work with the subscribers. It's not so straightforward. So I encourage you to check out the sample that I put in the description and try it out on your own code and see how it works and see if it will work for you in your particular application. Sometimes simple is best. I mean, it really depends. The more complex things. So I would say one thing that someone had mentioned last week was the application event manager, and I believe that's a piece of Nordic code. So, and that actually does something. I think they're almost exactly the same, if not the same. I know this was not written by someone in Nordic. I believe this is actually written by different individual, but they develop Nordic's version of this is very similar. So, okay, Brian, you're welcome. Thank you. All right, that is it for today. I really appreciate you being here, and if you have other ideas for things that you like to be see covered, throw them in the description box below, and I will try to cover it on the next session. And thanks for being here, and we'll see you on the next one.